Another protocol you might want to be familiar with is domain name system or DNS. DNS is essentially a translator that corresponds IP addressing with an associated human-readable domain name. Every website on the internet has its content stored on a server. These servers have IP addresses assigned to them that make locating the resources saved on them possible. When the internet started, it was easier for people to correspond to specific IP addresses with specific computers. But that didn't last long as more devices and people joined the growing network. While it's still possible to type a particular IP address into a browser and reach a website, users wanted website names that would be easier to remember. Of course, it would be nearly impossible to accurately memorize the IP addresses of the many websites we visit today. Imagine having to type a bunch of decimal numbers just to access Facebook, Twitter, Gmail, YouTube, and all the various services associated with these companies, which are often hosted across various servers with different IP addresses. That would be by all means boring, to say the least. We just want to be able to type google.com into our browser and be taken there without a fight. However, as we pointed out previously, routers work at layer 3 and they need layer 3 IP addressing in order to forward packets for us. So we need DNS as a translator in the middle that says, here is the IP address that corresponds to google.com or whatever other domain you're trying to reach. A good way to understand how DNS works is comparing its job to that of your mobile phone book. As you know, your SIM works with phone numbers to be able to make outgoing calls or send messages. But you can't possibly start memorizing the hundreds or thousands of phone numbers associated with your contacts. Your phone book helps you tie these large numbers to a simple, easy to remember name that you choose for each number, such that when you search for, say, Peter, for instance, your device will easily locate 123.234.000.000 or whatever you assign to Peter on your contact list as his phone number. The DNS works in basically the same way. In the example on screen, we have a desktop computer, and let's say we're trying to reach google.com. Google.com is currently on a server with IP address 172.217.170.174. The desktop user, of course, does not know what the IP address of the web server they are trying to reach is. However, the desktop computer does already know about the DNS server's IP address that is saved in the computer's configuration. You should know that the DNS server in this case is at 192.0.2.10. And when a device receives valid IP addressing information, often through DHCP assignment or maybe that's manually assigned, the network adapter is notified about the DNS server that it should use. And that DNS server's IP address is saved with the addressing configuration for the network adapter. In fact, let me jump over to Kali Linux really quick and just show you how this works in my case. This information will appear differently in Windows. This is a Linux specific command. So I'm going to say cat/etc/resolved.conf. And if I hit enter, you see that this displays a configuration file in Linux that lists the current DNS servers that are known, which you can see are my default gateway 192.168.0.1 and a Google name server, which is 8.8.8.8. The Google name server is very commonly used as a backup or even a primary DNS server. How does my computer know about this? Well, in my case, I actually manually configured the DNS settings for this virtual machine. Again, in most cases, that's learned via DHCP when the computer is booted up. That way, we know where our DNS server is located. But in this case, even though we know where the DNS server is, we don't know what the google.com IP address is. When the computer tries to reach google.com, it's going to reach out to the DNS server and it's typically going to say, "Dear DNS server, what is the IP address of google.com?" And that message is going to go out over port 53, which is the well-known port dedicated to DNS. The DNS server is going to respond and say, "This is the IP address that you're going to want to use to reach this google.com. The desktop computer will then take this information and use that to send traffic to the destination IP address that was provided by the DNS server. If that's going out to a website that is using HTTP, in other words, a non-secure website, that's going to use port 80. If it's an HTTPS website, that will use port 443. The web server will respond and say, here is the web page that you requested. So the desktop computer, only knowing the domain name, was able to reach the server thanks to the DNS translation that happened. These domain names are what we call an FQDN, or fully qualified domain name. This could be a normal website that we're trying to reach. It could be an FTP site. Lots of options here. Let's also talk about the structure of DNS, which, like many other structures in networking, is hierarchical. In other words, they are organized in order of rank or importance. So at the top of DNS, we have what are called root domains. Around the world, there are roughly 12 companies that take care of pointing us to DNS servers that know how to get us to .com addresses, .edu addresses, .net addresses, and so on. Those addresses are called top-level domains, or TLDs. Of course, this is not an extensive list of TLDs. The few I mentioned are just examples, .com being the most popular that we use. Under each top-level domain, we would have second-level domains. Again, this is not an extensive list, but just a few examples. So google.com is a valid domain. Google is the second-level domain. .com is the top-level domain. Now, of course, with many websites, you notice that we also have subdomains within those second-level domains. Subdomains are something we'll talk about in details a bit later in this course as well. So you might have ads.google.com, images.google.com. In this example, ads is the subdomain, Google is the second-level domain, and .com is the top-level domain. For most websites, the subdomain points to an IP address or resource different from the second-level domain. Here again, the DNS helps lead us to the right place.